Hello students, in lesson number 10, light, reflection and refraction, let us move further. In the previous lecture, we have learned about the image formation by a plane mirror. Okay, how the plane mirror forms a mirror behind it. Now, today we are going to learn about the types of mirror and some of the few terminology related to it. Mainly, there are two types of mirror: plane mirror and curved mirror. We know that plane mirror is a flat mirror, right? And curved mirror, which is also called the spherical mirror, this have not the plain flat surface, okay, but it has curved surface. So, further, the types of curved mirror, based on the reflecting surface, okay, which surface of curved mirror is there, based on that the curved mirror is of two types. First is concave mirror and another is convex mirror. See, spherical mirrors are the part of a sphere, okay. Imagine a hollow sphere of glass. From this hollow sphere, which is completely empty inside, okay, from this hollow spherical glass, a small part of the glass is cut, okay, small part of the sphere is cut. So that part of the sphere is considered as a spherical mirror, okay. So consider these two spheres. Out of this, okay, this dotted line shows a whole sphere of glass. Out of this sphere, this small part is cut. Now this small part, does it act as a mirror? No. This is the surface of glass, okay, so and light can pass through the glass. So only glass is not act as a mirror. We have to coat on one side, okay, so shaded part, okay, coating on one side of the mirror, one side of the glass surface, then that surface will act as a mirror, okay. So here, from a mirror, we have cut part of it, okay. Now this two part can be made a mirror, but depending on a coating, okay. If we coat on one side, the mirror can be made. Now point is, which side do we coat? So based on the side we coat, we share, okay. The curved mirror is of two types. First one, if we shade the mirror from outside, right? Okay, so back side of the mirror is shaded or coated. So reflecting surface is inside, light will on optic side light cannot incident, okay, and cannot be reflected. Okay, so reflecting surface is inside, and on the other case, if we coat the mirror from inside, then the reflecting surface will be outside. So if the reflecting surface is curved inward, okay, inward surface is reflecting, okay, so reflecting surface is curved inward, that mirror will be a concave mirror, okay. So how can we define concave mirror? A spherical mirror whose reflecting surface is curved inward and shaded outside, okay, that will be the concave mirror. And opposite to it, a spherical mirror whose reflecting surface is curved outside, this is the reflecting surface, and shaded inside, that surface, that mirror will be known as convex mirror. Okay, so understand the two basic type of mirror: concave mirror and convex mirror. Concave mirror will be reflecting inward and convex mirror will be reflecting outward. So light will be incident on this. Okay, so it is bulged outside and it is inside. Concave mirror will be inside. Now the image, how this image, we know the image formation by the plane mirror. Okay, so the the properties of this curved mirror is different than the plane mirror. So the image formation by these two mirror will also be different. So before going to the image formation by this curved mirrors, first one we learn some of the few terms, important terms which is used in the image formation. So let us see some few terms related to this curved mirrors. So I have taken two mirrors, one is concave mirror, one is convex mirror. Concave mirror reflecting inside and shaded outside. Convex mirror reflecting outside and shaded inside. Now, terminology. First is pole. What is called pole of a mirror? The center of a reflecting surface of a spherical mirror is called a pole, which is denoted by capital P. Okay, so reflecting surface. This is a reflecting surface, and this reflecting surface has a one center. So then this one will be the center, exactly midpoint, that will be the pole of the mirror. Let me introduce a point P in a mirror. So that P will be the pole of a mirror. Same way for the convex mirror, the center of a reflecting surface is called the pole, that is denoted by capital P. And we can say that pole P lies on the mirror. Okay, that point is on the mirror. Now, second, center of curvature. What is center of curvature? We know that this curved, this spherical mirror is a part of a sphere. Okay, part of a whole sphere. And that sphere has one center, right? That center is called the center of curvature. So how can we define it? The center of the sphere from which the mirror is cut. Okay, this mirror is a part of one sphere, and the center of that sphere, the whole sphere, is called the center of curvature, which is denoted by capital C. Imagine this is a whole sphere, and that sphere will be having one center. Say here. That will be the center of curvature for this surface, for this mirror. And for the convex mirror, same. This convex mirror is a part of one sphere, and that sphere has one center, which is known as center of curvature. And as you can see, this center of curvature is not a part of the reflecting surface. It is outside the reflecting surface. Okay, only pole P is on the surface, lies on the surface. So it is a part of a mirror, but center of curvature is not a part of mirror. That is denoted by capital C. Next, radius of curvature. How can we define? See, this sphere from which the mirror is, our mirror is a part of a sphere. Okay, and that sphere has some radius. That radius will be the radius of curvature. Okay, so radius of the sphere of which the spherical mirror forms a part. Okay, our sphere is a part of that spherical part of that sphere. Okay, so radius of that sphere is called the radius of curvature, which is denoted by capital R. These terms, okay, the symbols are very much particular. Okay, so capital R denotes the radius of curvature. What will be the radius of curvature? From center to any point of the sphere will be the radius. So CP will be the radius of curvature. Yes, which is denoted by capital R. Same way for the convex mirror, center and the pole. Pole is on the mirror, so center to any point on the mirror will be the radius. which is denoted by capital R. Next, principal axis. What is the principal axis? The imaginary line passing through the pole P and center of curvature of a mirror is called the principal axis. Okay, we imagine a straight line passing through this pole and center of curvature. Imagine this. Okay, so this line will be a principal axis which pass through the center of curvature and pole P. For the seeing ray, for the convex mirror, imaginary line passing through C and P is the principal axis. Next, principal focus. This term is very much important. Very important term, principal focus, which is denoted by capital F. What is that? A parallel rays of light. Okay, so for that we are taking a parallel rays of light. Okay, a parallel rays of light incident on a reflecting surface. So let us take some of the rays. Okay, so parallel rays of light is coming and incident on a reflecting surface. For concave mirror, the reflecting surface is inward. And for convex mirror, the reflecting surface is outward. So the mirror on the reflecting surface only the rays are incident. Right? Now, the parallel rays of light incident on a reflecting surface. Now what happens when the rays of light incident on a reflecting surface? They reflect. Due to the coating, they will reflect, doesn't pass through. So how they reflect? Okay, it is not a plane mirror, so they will reflect in a particular direction, obeying the laws of reflection. Okay, so due to this inward curve, the rays of light will reflect in a particular direction. Can you understand this? Due to the inward curve, the rays of light will be reflecting in such a way that they meet on one point. And that point will be the principal focus. Right? What about the convex mirror? This is due to the outward curve. The rays of light will be reflected in a diverge way. Okay, they are diverging. So what happens? They are not going to meet. But so if the rays are not meeting, if we extend that rays on the back side of the mirror, they appears to be meet on that point. Okay, for a complex, due to the outward curve, the rays will be reflecting in a diverged direction. Okay, so they are not going to meet. So they looks like they are coming from this point. Okay, if the mirror is not there, the rays will be looking like they are coming from this point. So that point will be the principal focus. So let us see the definition. The parallel rays of light incident on a reflecting surface, they all meet or appear to meet. They all meet or appear to meet at a point on a principal axis after reflection. This point is called principal focus F. Okay, the rays should be parallel and the parallel rays only meet at one point. And why they are meeting? Due to the curved surface of a mirror. Okay, obeying the laws of reflection, like that incident angle is equal to the reflecting angle. Okay, so obeying this rule, they are reflected in such a direction that they meet at one point or appear to meet at one point on a principal axis. That point is called the principal focus, that is denoted by capital F. Now next, focal length. The distance between, what is focal length? The distance between pole and principal focus is called focal length. Okay? This focal point on a principal axis and pole, the distance between these two is known as focal length. So this distance is called the focal length. Similarly, for convex mirror also, the distance between the principal focus and pole is called the focal length, which is denoted by small f. The focal length is denoted by small f. You can see here, CP is the radius of curvature and FP is the focal length. The relation between this radius of curvature and focal length is given like this. F is equal to R by 2. That means focal length is a half of radius of curvature. Right? Okay, so this is proved. Okay, this relation of F and R is proved that always for any mirror, convex or concave, the focal length is always half of the radius of curvature. Okay, so this relation we have to remember. So these are the very important terminology related to mirrors, curved mirrors. One important thing is that any curved mirror, okay, any curved mirror have some end points. Okay, so this and this is the outline of a mirror. So the diameter of this extreme point, okay, it's not a complete sphere. So diameter is not the actual diameter, but for any reflecting surface, the diameter of the extreme points, diameter of the surface, reflecting surface, that is, if we join two endpoints of the mirror, that diameter is called aperture of the mirror. Okay, so let us say this point is M and this point is N. So Mn is the aperture of the mirror. Similarly here, Mn will be the aperture of the mirror. This aperture is defined because mirror have different curvatures. Okay, so the aperture will be small, bigger, etc. Okay, so this aperture is also one important term for the mirror. So wherever the mirror is chosen for this image formation, it is also taken in consideration that of which aperture the mirror is taken, right? So this was about the very important terms related to spherical mirrors. So we'll use these terms in the image formation by spherical mirror. So read up to this, and still if you have any doubt, you can ask me. Thank you.